Hello everyone, how are you? In this episode, I'd like to discuss about authorization. Now, when you are building applications, it could be serverless applications or containerized applications, it is important to focus about authorization. And today in this episode, I'd like to share some of my thoughts related to authorization, and I will use this diagram in order to convey those messages. Now let's imagine that you are building a full stack application, and one of my high recommendation is to use AWS Amplify for your clients. It could be like a mobile application or mobile client or a web client. Just use AWS Amplify because this is going to give you a lot of benefits, particularly related to security as well. Now, your backend could be, built using serverless framework or even AWS Amplify CLI or SAM framework or whatever the serverless framework that you are used to. That's all right. But when you're connecting to those backend resources, I would recommend you to use AWS Amplify because one big benefit that you will get from AWS Amplify is that it will keep refreshing your tokens. So as soon as, let's say, a user logged into application, so you don't have to necessarily worry about when to expire their token and how to refresh those tokens and so on. So Amplify will take care of it. And also Amplify has a lot of libraries, or the Amplify library really helps you to securely connect to your AWS resources. So whenever you have some credentials, temporary credential, we'll talk about temporary credentials and how you can acquire them. And whenever you have some temporary credential in your client, you can directly connect to your AWS resources. For example, in this case, I am accessing an S3 bucket directly from the client, not through the backend, right? So this will be even faster. So your users will have a good experience, right? So yeah, so that's one of the recommendation to use AWS Amplify. And then if you have, let's say, a backend that is based out of a RESTful API, I recommend you using API Gateway. And there are two modes to this: HTTP API or REST API. And REST APIs provides a lot of other functionalities like throttling and so on. But if you want some lightweight API with low cost, HTTP API is a very good candidate. So regardless the API is, I think you should use a managed API. So here in this case, I'm focusing on a REST API with all the full features, right? So API Gateway is a managed service, like I mentioned. And in the API Gateway, you can define different authorization methods. Now, some of the popular authorization methods are these. Actually, these are the four main types that API Gateway supports. Usually, we use Cognito User Pool Authorizer to authorize all the requests from the client who logged into the application through a user pool. And if you have, let's say, specific authorization logics, and if there are like a lot of business logics involved into it, then obviously a good choice is to go ahead with a Lambda authorizer. And API Gateway also supports IAM. So that means your application that assumes a proper IAM role can communicate your API Gateway if you configure, this IAM method. And also we have the resource-based policy. Now this is one of the less used one or less popular one, I would say. Just like S3 buckets where you can apply a resource policy, you can also apply a resource policy at the API Gateway level. Now, unlike IAM or Identity and Access Management policies where you apply it at the users or the roles, these resource policies are pretty much similar as IAM, but you apply it at the resource level. Now, the resource that we want to provide access is the API Gateway. So we will apply a resource policy, and in the resource policy we will indicate what entities are able to access this resource. So so that means, I mean, our entities or the users or any clients that are going to consume our API Gateway do not have to have any IAM role or anything, they can try to access it, and if they falls into the entities that we whitelist in the resource policy, then they are able to access API gateway. But today we are going to mainly focus about user pool authorizer, because I think you can handle most of your authorization requirements through this user pool authorizer. So the next entity I want to have a good discussion is on AWS Cognito. Now I told you the users are logged into a user pool. Now it is a good practice, and I think it's a best practice to decouple your users from your application, so that you can scale your users independent to your application, and that's a very good practice. So in order to do that, again you can use this managed service, the AWS Cognito managed service, and it will provide you actually two things. One is the user pool itself. You can add all your users into it, and Cognito provides all the industry standard authorization protocols like OpenID Connect, SAML, O2, and so on. And also it will give you the opportunity to connect with third-party identity providers, or the web identity providers like Facebook, Google, LinkedIn, and all these web identities as well. You can connect it to Cognito. And one of the really good thing about Cognito is that even you have multiple other identities, web identities like Facebook, LinkedIn, or it could be like corporate identities like SAML, which is used in Azure Active Directory or so on. You can have all these identity providers connected to your user pool, and then user pool will generate its own tokens, refresh token, ID token, and access tokens. Now these tokens are generated at the Cognito, so then your applications, all the backend application can rely upon the same set of tokens. I'll give a little bit of a introduction to that in just a bit. So it's a very good choice if you really want to have a better user management in your application to use AWS Cognito. And another component that comes along with the Cognito user pool is the Cognito identity pool. Now earlier I told about there's a way that we can fetch temporary credentials to your client directly, and that is made possible by the identity pool. So if you don't have identity pool, if you only have a Cognito user pool, it will return you the tokens once the user logged into the application, usual JW tokens, ID token and access token. And those tokens, then again you can use it at the API gateway to authorize the request. If you are particularly using user pool authorizer, you can directly configure it, and that's all right. But if you want to have some additional permissions, like in terms of temporary credentials, where you want to connect to other AWS services like S3 bucket, for example, let's imagine you wanted your users to upload their profile images to S3 directly from the browser, then that's where these temporary credentials really comes in handy. So in order to do such things, you need to have temporary credentials, because you don't hard code any long-term credentials in the clients, which is a highly bad practice, but instead you will use these temporary credentials that is returned from the Cognito identity pool. So this is how it happens. So when a user logs into the application through one of the UI components in AWS Amplify, and that's another plus point for using AWS Amplify. You are presented with a lot of built-in UI component for different front-end framework, React, Vue, Android, or anything. So when users log into Cognito user pool through, let's say, such UI components or any custom-made UI component, then Cognito user pool generate these OpenID Connect tokens, access, refresh, and ID token. And if you have this identity pool also configured with your Cognito user pool, then it will forward this token to the identity pool. And then identity pool has two main roles. Now one role is authenticated user role, and the other role is unauthenticated or the guest user role. So identity pool will check whether this user has logged in properly, and if he's logged in, then it will use the authenticated role, it will assume the authenticated role and it will fetch the temporary credential from STS or simple security token service. So it will then return these temporary credentials such as access ID, secret key, and also session token. And then those temporary credentials will be passed down to AWS Cognito, and users or the clients will receive both tokens plus those temporary credentials. Then you can use these temporary credentials to access additional AWS services. And in order to do that, again, Amplify library is really helpful, because Amplify libraries, they use SIGV for signing for you, and they will directly use the temporary credentials that was written through the user signing. So you don't necessarily have to do any other configuration but to use these Amplify libraries to connect to whatever the resource you want to. Yeah, so the next part is about how we can communicate with our API gateway securely. So in that case, guys, the token that we return through the signing, it includes ID token and access token. In most cases, we use ID token. I'll tell you the reason as well. And also you can use access token as well if you have a separate resource server where you need to have some custom scopes defined and get the users authenticated or authorized through that. But for the most part, in most use cases, we use ID token, because in the ID token, it will contain different claims. Usually with OpenID Connect, there are a set of standard claims. What's the name and expiry date and so on. On top of that, you can add some custom claims as well. Now, when you're creating a Cognito user pool, you can add these custom claims. For example, let's say the tenant ID. So you can add the tenant ID as a custom claim, and also let's say you can add the subscription. Let's say in this case, let's assume we are building an online course sort of a website, and now let's say when the users sign up for the application for the first time, they will get the free subscription, and of course they can update it to premium subscription in the application itself. So those information that is related to the business logic can also be stored as claims. So that's a good thing, because then when these tokens are generated, guys, those information will also be presented to us in the ID token. Then usually what we do is, whenever we want to call our API gateway and protected route, let's say this is a protected route, you will pass down that authorization token in the authorization header. So this HTTP request header authorization will pass down the ID token. And then API gateway, since we have configured it to use the user pool authorizer, it has the ability to check this ID token against the Cognito user pool, whether this token is valid and it's not expired. And depending upon that, it will be able to grant access to the backend logic. In this case, it will trigger a Lambda function, get causes Lambda function. Now, here's the thing, guys. If you are using API gateway with user pool authorizer, the API gateway will only check whether the user is available in the Cognito user pool and if he has successfully logged into the application. If so, he is given the access to the backend resources. If not, it will be rejected. Now, usually our application contains some more business logic when it comes to deciding a user has access to a certain resource. Now, let's imagine this is an online learning application where the signed in users can belong to different subscriptions. Now, for example, let's say there are two types of subscription, premium and standard, and premium users can access to, let's say, quizzes as well. But the standard users with the standard subscription cannot access to quizzes, but both the premium and standard users, they can access to the courses. And apart from that, there will be some premium specific videos where from Amplify in the client itself, you can stream those videos from the S3 bucket. So these videos are also only available for the premium users. Now, such a situation, how can we handle? Now, I already mentioned user pool is only deciding whether the user is available in the user pool or not. So, if you want to add some more conditions into our access control, now there are multiple ways that you can accomplish this. Now, let's say we still want to use our user pool authorizer, regardless it's only checking whether the user is available in the user pool or not. In that case, when we create a user in the Cognito user pool, we can add them to a Cognito user pool group. So, when a user subscribes for the standard subscription, we can create a user pool group called standard. And that user gets added to the standard user pool group. In Cognito user pool, you can associate an IAM role with that particular user pool group. So in that case, we can have an IAM role defined with the permission policy, which has full access to the course, but denying access to the quiz table. Now, not only that, but we also want to make sure our standard users do not access our premium videos. So maybe we can use the same role to update the S3 bucket access as well. For example, we can add a deny IAM permission for that standard group role. And we can also create another group called, let's say, premium. And in the premium, we'll remove that deny permission and we'll explicitly allow both access to the quiz table as well as premium videos S3 bucket. Now, when the users sign into the application, those tokens will be generated, ID and access token. Now, in the ID token, there will be a claim called role. Now, this role includes the ARN of either the standard role or the premium role. So, what happens is, then Cognito user pool will forward that token to Cognito identity pool. And in the identity pool, we can configure it to use the token or use the role that is coming in the token. Now, let me quickly show you that one. Now, this is a user pool I just created. If I go to the federated identities, but before that, let me show you the Cognito user pool groups and their attached IAM roles. Now, I will go to here. And then I don't have any users. Of course, I can create users when they sign up for the application. But if I go to the group section, then I will see these two types of groups, premium group and the standard groups. So users with the standard subscription will be added into this group. Users with the premium subscription will be added into this group. Now, if I open, let's say, standard group, then you can see there's this ARN role ARN attached to it. Similarly, we have the premium group and there's also an ARN attached to it. Now, when a user signs into the application, they will receive the token. In the ID token, there will be this group name as well as the custom role ARN as well. Okay, now let's go to the federated identities. Now, as you can see, these are the two default roles I've been talking about, unauthenticated role and authenticated role. But instead of using these two roles, I can tell identity pool, hey identity pool, since Cognito is authentication provider, make sure to use the role that is associated in the token. Now you can click here and select choose role from the token. Okay. Now this will look at the preferred role claim in the ID token and then associate that role ARN to fetch the temporary credential from the STS. You can save changes. Now, when the tokens are being forwarded from the Cognito user pool to the Cognito identity pool will have a look at the claim section in the ID token and it will get the preferred role and that preferred role will contain, if the user is a standard from the standard subscription, then there will be the role ARN of the standard user role and then it will assume that role and make that assume role API call to STS security token service, and it will return the temporary credentials for that role. And then both tokens and the temporary credential will be returned to the client. So from AWS Amplify library, then when one of these users try to access the premium user bucket, they won't be able to do that because there's a denied permission for that. But on the other hand, if the user is a premium one, the Cognito identity pool will assume that role and get the corresponding temporary credential. Then from client, we can directly access our premium videos and stream them to the client directly. So that part is all good. But how about we will set some access control at the Lambda function level. So let's think about it a little bit. Now I think you guys agree with me, it would be really great if my Lambda function can also assume the same role. You know, if the user is premium user, the premium IAM role. If the user is standard user, standard IAM role. So that we will automatically blocks standard users from accessing our quiz table, because we have assigned the same deny permission in the same role for the DynamoDB table as well. But unlike in AWS AppSync APIs, when we use Lambda with API gateway, the Lambda functions do not inherit that particular role automatically. In AWS AppSync, we can do that. Now instead, what we can do is we can manually assume that role. Now I'll show you an example. Now here in this blog post, how do I allow API gateway REST API users to run a Lambda function using execution role from an Amazon Cognito user pool? So in this blog post, they have nicely explained how to do that. Now here they are using Python, so they use Boto 3 SDK. Now this is available for JavaScript as well. So this part is the most important part. Now here in the Lambda function, we can access that role ARN by diving into the event object. So in the event, we will have the request context, and inside that authorizer, claims, and finally this Cognito Roles. So it will return the role ARN, and then I can use AWS SDK, in this case the Boto 3, and here I'm using the STS assume role API call. And as the role ARN, I'll pass that role ARN, which I just got it from the event object, and then I can add any session name as well. So as the return values, we will get those temporary credentials. So I will have the access ID, secret key, and session token. Now I can use those temporary credentials to make requests to my DynamoDB. Let me show you that in another example. Have a look at this one. Now here they are hard coding it, but assume like we are passing down those role ARN and the session name. And after that, we can get the access key and the secret access key and the session key. And in this example, it's accessing S3, but similarly, we can use AWS SDK to access DynamoDB as well. So if it is a standard user, when they try to access quiz table, it will be automatically denied through the permission policy. Now what we just discussed with the user pool authorizer, it was using one of the already created IAM role. But let's say you want to create an IAM role on the fly, kind of a dynamic IAM role or IAM permission policy. So if that is the case, then you can actually use the Lambda authorizer instead of user pool authorizer here. Now in the Lambda authorizer, I told you there will be a Lambda functions that always will forward the permission policy to the API gateway, and that permission policy will decide even which API paths can this request access as well. So it is more flexible. Now let me quickly show you an example of that. Okay, so now this is an example of our custom authorizer function. Now one big difference is, unlike in user pool authorizer where the token validity is automatically checked for us by API gateway, But here we need to manually do that because this is a Lambda function that we handle all the code in it. So here we first have to make sure the token is indeed generated from the user pool of ours. So we can use it using JW case. And then we have to make sure the token is not expired. So we have to check the validity of the token as well. And you can use any libraries for that matter. And once those two are confirmed, then we know, okay, this is a legitimate token. And after that, we can add whatever the custom logic. We can crack open the token and look at all the custom claims. And depending upon these custom claims, you can maybe query some tables and get more data and add that data into the context that we are passing down to the Lambda functions through the proxy integration. So you can do all such things. So it's very flexible. But ultimately, you need to pass a policy object into the API gateway. Now, this policy object contains principal ID and also the policy document. Now, this is very important. So, policy document is nothing but another permission policy, IAM permission policy. Let me quickly show you that one. This is the policy.json. You see, now this is a policy permission policy. And there, I'm picking my user role. Let me show you that one. So from the token claim, I get what the role of the user is, and then I will pass that role name into this policy JSON. So then it will pick the corresponding JSON object. If it is a user, this is that. Or this could actually be standard, right? And this could be, let's say, premium, or this could be like super admin or whatever, really, right? I can deny access to different API gateway paths because now this policy document is getting forwarded to the API gateway. So there will be this other Lambda function, this custom authorizer Lambda functions like this, or Lambda authorizer. Now here the policy document is getting applied to the API gateway, not to the Lambda directly, right? So in the API gateway, then with the policy document permission policy, we can tell, okay, allow only the get causes. Let's say there will be a path that invoke this Lambda function, right? So we can allow that path for both premium and standard users. And this quiz table would be a different Lambda function altogether. So it's like this. So let's say this function is get quizzes, and it will invoke this Lambda function, sorry, this DynamoDB table, and there will be another path from the API gateway like this. So the permission policy that I applied there, I can restrict access to this quiz path altogether. So like this. So I can just say quizzes, just deny access to the quizzes for the standard users. But for the premium users, they can access to that. They can access to that, but there will be a deny access to, let's say, there will be a super path where only the super admins can access. So likewise, we can, with much flexibility, we can define these access policies. And the items that is there in the context object, this will be passed down to the Lambda function. So I can access all this context data in the Lambda function itself. I hope it's clear. Now this is what I want to cover in this video, guys. So if you have any questions, please post it in the comment section. I'll do my best to answer that. Thank you very much.